Hi guys, welcome back. So here we're going to just finish up this little section here now. So if you have a look here at the labels that we've used in the original video, we were just talking about labeling the angles and then some of the symbols that you may use. Now I want to move over to these symbols over here. We can use θ1 to represent the angle of incidence and θ2 to represent the angle of refraction. Now, refractive index is kind of a measure of how much a material is able to slow down and affect the speed of a wave. And normally what we say is the refractive index of air is 1. Now, what this allows us to do is create some context to our equation. So Snell's law, which allows us to calculate refractive index, states that the sine of θ1 over the sine of θ2 is equal to the refractive index of the secondary material over the refractive index of the entry material. So now if you consider what we've just said here, the fact that the refractive index of air is 1, when we do this calculation, what you're going to get is it's always going to be a number divided by 1. Hence why in a lot of textbooks you see that n1 is actually removed from the equation. Okay, so this is the basic introduction. So for example, let's say θ1 was 30 degrees, so we'll just note that down here. So let's say we had sine 30 degrees and we didn't know sine θ2, and we knew the refractive index of a material, let's say a glass block, was 1.5 over 1 because it's coming from the air. From this calculation, we can simply do our rearrangement and we'll get an angle for θ2 being 19.5 degrees. Fairly simple rearrangement, fairly straightforward, and quite a basic calculation to do, but just a little bit of context on what these symbols and numbers actually mean.